Okay, so we have a workshop today, and this is going to be a quick video on how to do a speed testing on say that you have two algorithms and you want to test whether one is faster or not. This is one way to do it. Of course, you know, there are different libraries and frameworks that do that for you in a better way, but this is, you know, just a sample test. So today we will be doing we are gonna check if bitwise shifting is faster than multiplication by a power of 2. Okay, so first of all, to do this, it's the same way as you would do it when you time your friends running, right? So you have a stopwatch, and yeah, it's pretty much the same. So stopwatch, and then timer. Let's call it timer equals new stopwatch. Okay, and what do I need to do for this to work? Using something. Okay, what's the easy way to add this using something? Control dot using system dot diagnostics. Okay, so now let's see how this works. So timer dot, and with the dot, this is from a previous lecture. You will see everything that is available for the timer. So let's have a look at what we have at our hands. I still don't have my zoom it, which is unfortunate. Okay, right, so I need to okay, so we have elapsed milliseconds, elapsed ticks, equals get hash code. These are not interesting. Is running. Then we have reset, we have restart, and I assume somewhere around here there should be also something like, yeah, so we have start, stop, and toString is available for every object. That's for, you know, every data type that we use, or just any type that we use. Okay, so I would assume that we have to do start here. Okay, let's wait a couple of seconds. So we had to use using system.threading. And then how did we stop the time on the console? I showed this in the first lecture. Thread dot sleep, and let's sleep it for some milliseconds, and then I have to stop it. So timer dot stop, and console right line. We have to do one of these. So timer dot, it's either gonna be let me get up. It's either gonna be elapsed milliseconds, or ticks. So let's first see the milliseconds, whether we get something or not if I change my project. Something went terribly wrong here. Okay, so speed testing is this, and we have here some demo. Okay, right, so let's have a look. Okay, so it works. It shows me the same amount that we told it to sleep. If we put elapsed, this looks a little bit better, so 1.5 seconds, right? So this is what we'll be using throughout our demo. But here there was one more, so elapsed ticks, and you know, some weird number of the processor ticks. So we're not going to be using that. We still can use it because we're just comparing the two. So if it's higher for one, it doesn't matter which we use. Okay, so right, let's do this then. So I will need to start my timer, and let's get a number. Let's say 5, and I would like to multiply this by 2. So sorry, not by 2. Let's do it 1024. You know, just so that it's a little bit bigger number. And then I want second number. So Control RR, first number, and then I press enter, and it's gonna rename it for me automatically. So second number is to compare, we will have to use the same number, right? So you know, just to be safe. I don't think it's gonna matter that much, but if I put something like 2 billion here, then it may be it may show different results. And then I want to have second number equals second number, then bitwise shift with 10. So this bitwise shift with 10, we agreed on that this is the same as multiply by 2 to the power of 10. Okay, if I do bitwise shift to the right, means division. Okay, right. Okay, so we have our timer. We want to stop it here. So timer dot stop, and I want to print it as well. So timer dot elapsed, and then I want to reset it. Okay, I can make a new one, but we don't have to. Just reset it. Okay, reset. Then timer dot start. We do the same thing as before, so it's good to, you know, have them separated in your code. It looks like a block. It's not really, but it's easier to read. So this is one operation from start to finish, and we'll be doing the same thing here. So dot start, we have our number, and what else? So now we have timer dot stop. Timer dot elapsed. So these all are functions that you don't need to know. I checked it on Google, and if you have to use something else, then just do that as well. I don't know this on top of my heart. Timer dot reset. So let's reset it as well. Okay, let's have a look. Let's run this. Okay. The second one is significantly faster, but can you tell me what's wrong here? There is something like very wrong with the example that I did. Okay, I only do it once, right? And this doesn't test anything pretty much. So if you only do it once, it's gonna you may be in between ticks, so one can take a little bit longer. So let's just see, this is 100,000th of a second, right? So we know that computers are fast and so on, but this doesn't show us anything here. So if I want to do what I have to do, well, we have to repeat the process many times, right, to see which one is actually fast. So instead of just doing this once, I'll be doing it, say, 1,000,000 times or something like that, and then we'll see what's gonna happen. So so 4, and then here I would like to put 1,000,000. Yes, delete this bracket, put it put it here. Sorry, just 1 second. Yeah, it should. I'll be fixing that. So I need my timer start to be here. But yeah. So there was a nice way. So pressing Alt, it moves it above. If that's what you want. So I'm holding the Alt, and then just with the arrows I can just change those. Okay, and then I have to put it down anyway. So yeah, so this is what we do 1,000,000 times. So I get a new variable, and then I multiply it by 1024 many times. And right, so then we stop it and so on. I I want to start it as well here. Let's make this 1 million as well. And take this bracket, put it. Ah, come on. For some reason. Okay. Timer dot stop, then we write it, and we've done this now a million times, so let's see. Well, the second one is slightly faster, but definitely not 3 times faster. And again, this is 100th of a second, so let's just put more. Okay, let's make it 1 billion times to, you know, just stretch the computer a little bit. Are these, you know, 3, 3, 3, okay, 3, 3, 3, okay. We have to wait a bit. Yeah, 6 seconds. It's not that much. Okay, so for a million operations, you know, it's not that much. So yeah, this is slightly faster. But when I was testing it on my PC, they were pretty much the same. So yeah, the bitwise multiplication is a little bit faster. But from the website that I've given you, it says up to 3 times faster. Which here is not the case, and the reason is that C# has its, you know, internal optimization of some sort. Like, this is the only explanation that I can get. So whatever you do, when you compile the code, is going to be, you know, somehow it's going to be optimized. So if you have something like multiplied by 2, instead of doing that, it's going to use the bitwise shifting thing, and it's going to make your program a little bit faster, so that you don't have to think about it. If you try other languages, probably like C++ or something like that, just raw, they may not have this kind of optimization. I'm really not aware, but I was expecting here like a huge difference, and then it's not there. So pretty much you don't have to worry about. There is a saying that premature optimization is the root of all evil. Okay, so first you write the code so that it works, and after that, if needed, you are gonna have to optimize it somehow. Okay, right. I think that's pretty much it for testing. You can test anything you want here. So the main point was how you test it. So you have a stopwatch, then you have some algorithm that you want to check how fast it is. If it's, you know, really fast, like an operation or 2, or maybe, you know, 100 ones, so it's going to be very fast, and you need to repeat this process over and over again to get consistent results. Because if I put this 1 here, the difference is like 1 second, which is what, like 10% difference. But when we put it this way, you know, just once, is this gonna less than 1? Yes, 0 is less than 1. So if we do this, you know, here the difference is like what, 5, 6, 7, 8 times faster, right? Which is not consistent result. It's only like 10% faster, and that's why we had to repeat this process over and over again. While we are on the subject, let's test the other thing, which we use for multiplication. So I'll copy all of this, and you know, change this to a billion, change this to a billion here, and change this to a billion as well. Okay, so the final way that we know of is first number equals first number times 1024. Right, so these are different. This is different from this thing here, right? It's just a different way of writing. So let's have a look. You know, it's going to be some seconds. There was a question in the meantime. Can we try with 2-digit and 3-digit number? Yes, of course. We'll. Interesting. So the final way which we did was pretty much the same as the previous. Again, another interesting thing is what happens if I put this at the top. Is it gonna be, you know, is there some delay on starting or something like that? We may have to test that as well. So I'll put this here and let's see what happens. So it was 5 and let's see what it is now. Okay, so there is something wrong here, clearly. How to fix this? I would say so let's just 1 second. So what I would do here probably is do a thread.sleep at the beginning. Maybe it will work, maybe it won't, I don't know. So thread.sleep. The reason is that there may be some delay when you start the program, and with the thread.sleep, everything below this line is going to be evaluated after, you know, let's say 1 second, and see what the results are there. You know, just test it yourself, everything that you want, you know, switching, making numbers bigger, smaller, and so on. So let's have a look what happens. So it's still 6. Right, so I don't know why this happens. Maybe something when initializing the timer and so on. I can put a different timer for each one and see if that's gonna help it. But this way is very clear that this operation is the same as this in time. So the computer does some kind of internal optimization of what you write, and this is not available for every you know, language and framework and so on. So you have to be happy that we are doing C#, because, you know, as you said, it's new and powerful, and Visual Studio is quite cool as well. Right, so there was a suggestion to increase the number. What kind of a number would you like, sir? 36. Okay, I was hoping for something a little bit bigger, but anyways, let's try 36 and see if there is any significant difference. So no, but I would like to try 1,000,000. You know, just why not? Are we gonna go over the int? What do you think? There. Well, if we do, we could just use long. We can actually compare the difference if we use big integer or not, right? So the program here really doesn't care what kind of a number we give it. Is still gonna be faster. So let's call this here, you know, base tests. And this one we're not gonna care about, because, you know, it's it gives you difference in times. And let's do this as well. So this was this was usual way of multiplication, and let me just put some, you know, a couple of spaces there. And here this is bitwise way of multiplication. Okay, what happens if we use big integer? You know, it's a good question to ask. So let's do this as well. So I'll copy all of this, which you should never do. Okay, so right, let's do big integer. And you know, the name really doesn't matter to us. And that's now we know that it doesn't matter which way we use, but let's use, just in case, with the multiplication equals multiplication equals, and then we did it by 1024, I think. Okay, so this thing doesn't work, and now if I press Control dot, it's not gonna work as well. This is why I have to go to my references, add reference, and we need system dot numerics. Okay, remember this because you know it's cool, and now there it is. I have an extra space, thanks. Can I put it here though? Yes, I can. So Control A, Control KD, and it's gonna, you know, make our code a little bit better. So, and there are some rules that there has to be a space between signs and so on. Whenever you have a plus, whenever you have an operator, you know, you have to have a space. But Control A, KD, and you're pretty much done. So let's have a look. Yeah, the last one, I didn't change the name for it, but we'll see what happens. Remember that big integer works with strings, so at least I would hope that it's slower. It's taking its time now. I don't know how long. Maybe we will have to wait. We have time. I have time as well. So, what's up? How's it going?
It's a beautiful day today.
It's a beautiful day, yeah. It's sunny and, you know, warm outside and so on. I'm not gonna wait for it much longer though. Okay, the fan went on. Somebody want to play League or Dota? Okay, I'm not gonna wait for it anymore. So let's just reduce those by a couple of zeros. So how many do I have? 1, 2, 3, 4, 5, 6. 6 zeros. 1, 2, 3, 4, 5, 6. Okay. Then here delete 3 as well, and here delete 3 as well. I hope I didn't make any mistakes. So let's just, you know, to be sure. Yes, and I trust that the others are the same. Okay, so let's see. Well, a lot slower here, right? So all of these are pretty much the same, even with the base test with the delay that we've encountered. But so here is big integer. Okay, what happens if I bitwise shift this? Interesting. I want to see. Second number. Oh, pretty much the same. So, you know, the optimizations are still working, but you know, this is a lot slower. Okay, right, that's pretty much it. Any other questions?